So, this is What is Life Part 2. In Part 1, we talked about the 6 characteristics of all living things, or the 6 things that all living things possess. In Part 2, we're going to talk about the needs of living things. So, what are the things that all living things need? And you should have covered this, or talked about this, or seen this at some point in your school life. And we're just going to be a quick refresher, and hopefully, we'll add some more information for you. So, the 4 needs of life as we have them are energy, water, living space, and stable internal conditions. So all living things are going to need energy. And we talked about that a little bit in the last presentation. We said all living things use energy, and again, so it's a need also. Not only is it a characteristic, but it's a need. All living things need energy to live. Um, and again, autotroph is something that creates its own energy, and these are 2 processes that can be used to create their own energy, either chemosynthesis, which is using chemicals to create energy, or photosynthesis, which is using light to create energy. And so autotrophs either use chemosynthesis or photosynthesis. And then you have heterotrophs, things that get their energy from other sources. And that's pretty much what they do. They get their energy from other sources. So every time you eat a Big Mac, you are getting energy from another source. All right. And a little bit more about chemosynthesis and photosynthesis. Photosynthesis, as you know, is using energy from the sun to make energy or to make food for plants. Chemosynthesis, it uses chemicals to make energy. Most of the times you see that happening, as you see in this picture, down below the ocean, or at the surface of the ocean, deep sea vents where there's no sunlight, and so the bacteria down there, because there's no sunlight, they have adapted to using chemicals to create their own energy. So that's chemosynthesis. Next, we'll talk about water. All living things are going to need water. You always hear people say that you need to drink a lot of water. It's essential. 92% of your blood is actually made up of water, and it's a good solvent. It helps dilute chemicals. It helps flush you out. So all living things are going to need water to survive. And this little thing down here, Mickey Mouse, or water molecule, this is just a picture of the water molecule as you know it, H2O, so 2 hydrogen atoms, 1 oxygen atom. All right, so next we're going to talk about living space and why is living space important, and why is it a need for all living things? Well, we all need shelter, we all need living space to grow food or to have food, living space for water. If you remember in your history classes, all early civilizations that got developed and the ones that survived, they always settled near some type of water source. So again, they need some type of living space to access that water. If you look at that second bullet, it said there's a limited amount of living space on Earth. So we're going to have to compete for living space and share living space. So it's important that we figure out how to do that responsibly and not, over maximize our living space. Um, and I know many of you have seen the movie Hunger Games. Hunger Games is actually a good movie that talks about living space. If you remember District 8, it was just more people and the living space was less in District 8, I believe. So if next time you watch Hunger Games or when you watch Hunger Games 2, think of it from a perspective of how are they using their living space. All right. Stable internal conditions. So this is one, all living things need stable internal conditions. So if you're able to keep your stable internal conditions at a balance, then you'll be able to survive. Another word for that is homeostasis. So homeostasis is the technical term for keeping balance or keeping your stable internal conditions balanced. Some good examples for homeostasis or keeping your internal conditions balanced is when you get hot. So if you look at this little flow chart, when you get hot, what essentially happens is your brain triggers to tell your body that it's too hot, and that's going to send a message to your blood to flow closer to your skin or to flow a little bit faster, and then it's going to allow that heat to radiate from your body. Sometimes if you're still too hot and the blood flow doesn't help it, then your brain is going to send a message to say allow you to sweat, and it's going to activate those sweat molecules or perspiration molecules, and as those things evaporate off your skin, as the sweat evaporates off your skin, it cools your body down. So that's your brain trying to keep that internal balance of stable temperature or regular body temperature. So in order to keep stable internal conditions is something that's needed for all living things, and the technical term for that is homeostasis. Some questions for you to bring to class, and that's pretty much it for the four needs of life. So feel free to go back and look at this video again and make sure you understand those four needs. But a couple of questions we want you to work on: compare and contrast autotrophs and heterotrophs. So tell me how they're similar and how they're different, and give me an example of each. So an example of an autotroph, an example of a heterotroph. Describe why living space is a need of life, and contrast what might happen to a population of plants if you have two situations. One situation where there's not enough living space, so what's going to happen to those plants, and another situation where there is enough living space. What is going to be the difference in those two situations? And then the third question I need you to bring back to class is find an example of homeostasis or stable internal conditions that was not used in this presentation. So find another example of homeostasis besides your body becoming too hot and you sweating to cool it down and regulate that temperature. All right? See you for the next video.